Thank you, Karen. So welcome to this second part of the training session. So today we will go and pursue the flow of our method measurement procedure, and we will focus on mass spectrometry method and all the achievements and lessons we have learned during the instrumental development of our method. It will be an intense session, so we will have a break, a coffee break, and before to go on all the issue linked to the method validation, the achievement we obtain in our project dealing with mass spectrometry-based method, and we will present you the method performance and measurements reliability and the achievement and lessons we have learned. We will have some concluding remarks, and then we will discuss about the next step, especially the inter-laboratory comparison we are going to organize in the next coming weeks. So first, before to start in depth this session, I would like to ask you if you have some comments or new question about the first day session where we have present you all the preliminary steps of the measurement procedure, from the sampling, all the issue linked to the stability of the sample and the analyte in the samples, and also all the sample prep issue and quantification approaches to allow us to have reliable measurements of estrogens and complying with the requirements of the WFD. So does some of you have some questions and would like to discuss and come back to some of the points we have yet presented yesterday? So if not, I suggest that we start with the first part of the session dedicated to MS optimization. So I will So I hope you see my screen in full screen. So let's...
Sophie, we don't see the presentation.
Oh, so I stopped the sharing, sorry. Is it working now?
Yes, perfectly.
And is it in full screen?
Yes.
Perfect. So let's go to mass spectrometry method instrumental development. So just as an introduction, you all know very well that optimization and development of mass spectrometry approaches is always a compromise to achieve the lowest concentration in terms of intrinsic performance of the instrumentation. You need to also have compromise to have the more efficient separation, selectivity, sensitivity, and phase to matrix effects and background effects to allow you to have the best and more robust instrumental equipment. And it's not only a question of having the last generation of instrumentation that do not solve all the problem and issue we have to tackle when you want to really address so low level of concentration as necessary to achieve reliable measurements of estrogens in the environment. So here it is a picture. So yesterday, as we have discussed and introduced all the preliminary sample prep approaches. Now we are starting to discuss about the instrumental detection. And within the project, we have evaluated different kind of strategy for instrumental measurements. So both liquid phase and gas phase chromatography, coupled and if needed to both tandem, triple, quadruple mass spectrometer and high resolution mass spectrometer. So we have this overall set of starting as a starting point, and we have evaluated and benchmarked the different approaches with respect to the need of the project and the ambition of the project. So let's start with LC-MS-MS, and just to inform you, so within the project, we have only focus of interest on electrospray ionization approaches. Even if a PCI or a PPI could be relevant within the project because of the, I would say, the instrument available, and with respect to the purpose and objective of the project, meaning to have standardization and build standard, we saw that as electrospray was really the most unique and more relevant approach to be investigating in depth. So we only focus on electrospray. So here, what we will discuss discuss all the LC parameter optimization, colon, mobile phase, and show you chromatographic separation and discuss about this issue. We will investigate and show you MS-MS parameter optimization, so especially the choice of the IMRM and after the compromise between sensitivity and selectivity and experience we had in the project, and we will have a summary and conclusion with respect to this LC-MS-MS part. So first, we are investigating a wide range set of type of colon in terms of chemistry, in terms of length, in terms of diameter, in terms of porosity. And here you have there this overall set of colon. And here you see also the impact and choice of colon, the separation of the most complicating substances we have to focus on. I will of course say I'm of course talking about 17 alpha and 17 beta estradiol, and you will really need to achieve the best resolution to really be able to accurately quantify each of its isomer, and not only in standard but in matrix, in complex matrix. And here you see that you have a very different type of performance in terms of resolution depending on the choice of the colon. But you see really that you have really colon and chemistry that are highly performing in terms of resolution. So it is really possible to easily separate these two isomers. So here you have nice example of successful separation of both API isomer. So it's really to manage. You can achieve it either with isocratic or either with gradient approaches, but both are really successful. So it's easy to really achieve this separation. First point that we would like to discuss is the importance of the mobile files in terms of composition. So we have investigated different type of composition. Here is just an overview of small part of all the work that has been underpinned by all the partners, but here an example with that shows that with mobile files including NH4F, you can really increase the sensitivity of the instrumentation. So here you have the LD, so in terms of microgram injected, and here you have the different substances, and you see that it really makes a difference for the most challenging substances we add in the project, ethinyl estradiol. So really, NH4F is really interesting mobile phase to be added in the mobile phase to increase the sensitivity. And here you have also important examples. So showing you also the importance of the optimization of the content of these mobile files in terms of NH4F. You see here different content, and you see that it's not because you put high amount of NH4F that you will achieve the best sensitivity. The best sensitivity, you achieve it at lowest level of NH4F. So here you see nice example, and you see here the importance and the really that it is an additive that is really key to achieve and to improve the sensitivity of the method. Here you see, once again, the importance of the quality of your solvents to achieve the best sensitivity. Here you have experience of one lab using a different kind of water to prepare the mobile phase. Molecule water and molecule water of degraded quality. I mean, as instance, you can have some problems of your production system, and you can also have some holidays, you do not use it, and when you come back, you took water and you can have some trouble. And here is the example of the LCMS water. And what you see here is the impact of first the importance to have high maintenance and really to take care of your molecule water system. And here also the example that LCMS water are not necessarily the best strategy to achieve the lowest performance in terms of sensitivity. And here this is an example on 70 alpha 18 estradiol, which is still our key substances. So key message, have really cautious and really take cautious to the mobile phase. Still the same issue about this importance of having high quality solvents to prepare your mobile phase. Here it is really impressive. Old mobile phase, 3 days. Here a new one, and it is the same. You do not have drift within the instrument. It's the same day, but here you have the old one and prepare a new one. And what you see here is you have an enormous background, and you do not see your confirmation transition. And here, the same day, you prepare a new mobile phase and everything. Really be really cautious with your mobile phase. Let's go now to the importance of the choice of the condition of injection, so injection solvent and the volume of injection. So here you have different chromatograms showing you different methanol content in the injection solvents and different volume of injection. And what you can see is that it's not because you will inject important. Please, could you close your microphone if you do not speak? Thank you. So here you have the influence of the injection solvent, and you see that depending on the condition of injection, you will have tremendous impact on the resolution and the peak shape. So it is once again really important to have this compromise between the importance of having high ionization efficiency, so importance of having significant amount of methanol to have high efficiency in ionization, but it's not because you will inject more bigger volume that you will have the best sensitivity. So really it is really important to really have a focus on this optimization that could be really that could make the difference at this SO level and the level we need to target. And here once again we pursue in the importance of this condition. Here you have different tests with 5 microliter and 50 microliter injection volume, depending on the level and the content of methanol. And here, what you can see in this graph is that the best compromise was to have 30% methanol and not necessarily the big volume injection. And it really makes a difference. And here you see the concretization of that in terms of signal to noise ratio, transition of quantification, transition of confirmation, still on the 17 alpha 18 estradiol. Here you have the chromatogram showing you when you have in 100% methanol, 5 microliter injected. Here you increase the volume of injection, and here you have the best optimized condition, and you see that you have really a nice, very nice signal to noise ratio. So here I will not go in depth in this slide. It's just for you to when we will share you the slide, you will have all the information needed to implement that lab, but I will not go in depth. Here you have different optimized and successfully optimized conditions by the partner, showing you our chromatography, our mobile phase, and our condition, and just for you to implement at lab. And you see there the successful, and just a picture of the chromatogram showing you that we have successful separation in all these different conditions of all the different isomer. And when the separation is not perfect, we are specific by the mass spec. So everything to show you that you have successful separation. Now let's go to the optimization of the mass spectrometry, and we will detail and have a focus on the optimization of the source parameters to have the best compromise between selectivity and sensitivity that has been evaluated as signal-to-noise ratio. We will discuss on the ionization mode, free estrogen in negative mode, and at first. We will discuss about the importance of the flow, of the temperature, and we will discuss also about the MRM condition in terms of choice of transition of quantification, transition of confirmation, the importance of the ratio of both, and is this stability in different conditions and over the time. And we will discuss also about the critical parameter dwell time. So here again, just a picture that I will not go in depth. It's for you to take in hand and implement at lab if you would like. You have successful condition in different system. It is optimized condition, and I will not go in depth, just to show you and for you to have them at home. We will now go in more detail in some critical points. Here you have the presentation, of the importance of the choice of the transition. Here you have a chromatogram showing you different transition for the 17 alpha estradiol and in different type of matrices. And here you see the importance of the selection of this transition of quantification. You have here the evidence of important interfering compounds in the matrix. So here, just to show you that when you would like to go in so low level of concentration, the selection of the transition become critical. You can have interference that you will not see at upper level of concentration. So really be cautious and optimize at the lowest level of concentration. We have so many drawbacks in the within the project. When we address more complex matrices, we have been obliged to come back to the optimization of our instrumental method to introduce more specific transition, and we did not expect this drawback. So here, just to show you, there's been an optimization. Everything has been start from scratch, start from zero. And here you see that there is a more specific transition. So the method has been modified and new transition has been introduced to have more specific transition. And here you see that when we introduce this new transition, we fit and we are accurate in quantification. So this is really a key message we would like to share with you. Be really cautious with your choice of transition. And the choice of the more sensitive one for the quantification is not necessarily the best choice to be implemented. Once again, new example here with 17 alpha ethinyl estradiol, showing you that once again, we have some trouble with possible interference when we go at low level of concentration. So once again, be very cautious. No problem at 1 nanogram per liter, but when we go down 0.03, we see some trouble and we are unable to have accurate quantification in that condition. So be cautious. Here again, the method has been optimized once again. New transition has been introduced in the method. We overpass the issue of the interference and we are accurate. So very very, very cautious in that step. The same, you can have some drawbacks also, so be careful also with your transition, even with internal standard. Importance of the dwell time. Here you have the chromatogram showing you for, once again, 17-alpha estradiol. It is our critical points in this development. So here you have the difference between a dwell time of 54 ms and a dwell time of 400 ms. And here you see that just by modifying this, you have an increase in sensitivity and signal to noise of more than 2. So really, it is a message also. Multi-residue approach is a limitation. If you want to get sensitive and sensitive to target the challenge of the LOQ we need to target, multi-residue method is not possible. You need to have specific method to allow you to be in the best condition and to have the less compromise as possible. So this is once again one of our key message. Here, I will not go in detail. You have all the successful transition that has been optimized by the different partners in different with different instrumentation, and it is also for you to be able to implement at home easily. So our key message here are the best optimization for MSMS condition is not sufficient. You need also to have strong focus on the sample prep. We have shown you before. We have so many matrix effects and so many interfering compounds. And even if we have implemented purification and strong purification process, we nevertheless have had some. So this is our message. We pursue, and sorry, I think I go too quickly. This is just once more an illustration. Here you have chromatogram for estriol without purification step and with the purification step, and you see here the difference. So really, purification is not an option if you want to have robust measurements at the level needed. Once again, another example here, without purification, with purification, with the substances 17-alpha estriol. So you can tell us, yes, but they are not mandatory at this stage, but yes, but they are relevant when you want to have estrogenic information, and if you want to have the overall picture of all the estrogens. So really, this is example for those substances, but those examples could also be applied to our key estrogens. Here, once again, we have some partners also have bad experience about shift of the retention time for 17-alpha estriol, depending on the content of the matrix. So here you see the shift is important. So it means that really the matrix have strong influence in the chromatography, and you have to take care. And it is also why it is so important to have robust measurement, to introduce isotope dilution in the method. Here, once again, some example here on influence on the matrix and the importance of having isotope dilution. Here you have a chromatogram of a molecular water sample spiked with very low level of ethinylestradiol. The level here is a level equivalent to 1/3 of the new EQS of 17-alpha ethinylestradiol. And here you have the 17, you have here the internal standard. It is a deuterated one, and as you all know, with deuterated, we have some little differences in retention time, so it's quite normal. Here you have the same condition, but in the complex matrix. Here you have the new EQS level, and here you have a level which is, I would say, more comfortable for this approach. And you see here that without this internal standard, it will be difficult really to have this so huge, robust approaches. Internal standards is really key. Once again, some demonstration about the importance of the matrix. Here you have on another instrumentation, another approach. At in estradiol, here you have the chromatogram of the lowest point of the calibration curve, which is an equivalent of 2 micrograms injected of 70 estradiol. And here you have the internal standard. And here you have the same level. Sorry, you have the picture of the chromatogram in complex matrix at the level of the new EQS, and here you see that we have some important loss of sensitivity. Nevertheless, we are still in capability to have accurate measurement in that condition, and here you see that our internal standard really help us to relabel the quantification process. Here again, some example of the importance of the matrix. It is another method. Here you have the chromatogram, and you see here the distribution and the intensity of the different substances. All the picture are the same, show you the same theoretical level of concentration of the different substances we are targeting in the different condition. Here you have the low complex matrix. Here you have a mid-complex matrix, and here you have the high complex matrix. And you see here that we have very significant matrix effects, especially for estriol, which is first one to come in the elution gradient. And we have also some significant matrix effect. It's difficult to see here with intensity, but we have also general loss of intensity. So be cautious really with the matrix, and it's really a key message. Sample prep is really key for having successful quantification. Importance of quality criteria for identification and quantification of the compounds. Retention time, quantification transition, confirmation transition, the ratio of both of them, the importance to keep signal to noise ratios that are, I would say, realistic, so at least signal to noise of 9, importance of isotope dilution, and importance of injection blends in the series. Here, once again, some importance of quality criteria. An example for estrone. Here you have a calibration solution. Here you have an Evian water plus DOC plus SPM at a low level of concentration. And here you have the blank injection. And here we show you that we keep the signal to noise, the ratio of TQTC stable. We have good signal to noise ratio, and our blank are okay. Here you have a flow chart, I will name it like that, of the ratio of TQTC transition for 17 alpha estradiol at the QC it has 0.1, and here we show you the ratio, the evolution of the ratio among the time and among different series of validation in a method. So here we are in intermediate precision condition, and just to show you that it's quite stable. We have nevertheless sometimes we are out of our acceptance criteria. It means that it is really important to have this flow chart, and it is also important to keep the instrument clean, because really when you are facing some routine monitoring and high level of injection rate, I would say, in your instrument, you have really to take care to have prevent from drift by cautious cleaning of all the instrumentation over the time. But when you do that, you are in the pipe, and you are in the pipe also even at lowest concentration. Here, an example about the importance of internal standard. Here you have the signal of 17-alpha estradiol about the deuterated compound and in different conditions. And you see that we keep the signal to noise ratio. And even when the signal ratio go down because we are in internal standardization quantification approach, we are okay. So it is important to keep as message. Internal standard compensate about I would say, some lack of robustness of the method. It is really an important tool to implement. And this is once again here the demonstration here. Internal standard really fit with the substance they are supposed to quantify. Now we will go in another part of this presentation. We have, you all know that estrogen are very complex to analyze in LC-MS, especially in negative mode because of lack of ionization rate. And there's strategy to overpass it that rely in the implementation of derivatization approach. This has been done by some of the partners of the project. Two strategy has been investigated. The first one is the densylation approach, when you use a dicycloran and through a densylation protocol, you add this, this function to the estrogen. And doing so, you switch from AZ negative to AZ positive ionization, and you significantly increase the sensitivity. So it is really a strategy that could be interesting to overpass the limitation of lack of ionization efficiency in negative mode. I will go back in depth just after. And here you have the optimized protocol we have implemented, so you can also take it and implement it at home. It will work, and you just have to really be cautious in the condition of the densylation. You should really fix it, and if you fix it, it will be okay. We have made some tests in complex matrix. We have made some tests in and we have demonstrated that the ratio of densylation stays stable even in complex matrix. So it's okay, it works. An alternative strategy that has been investigating, it is a derivatization implying pyridine 3-sulfonyl chloride. It comes from it's based on a publication from Gleaner that has been recently published in 2018. And the advantage of pyridine 3-sulfonyl derivatives with respect to densyl chloride is that here the transitions are specific. It is a drawback with densyl chloride, the transitions are not specific. But we have compared both and we have implemented both in the lab. Here, of course, it changed the chromatography because you do not analyze the free form. You have at the separation level, you have the densyl or a derivative or a pyridine form, so it changed the chromatography. So here you have the optimized chromatography, and as you switch, you are not in negative mode. The mobile phase change also. So here you have optimized condition to be implemented. Here you have some pictures showing you the efficient separation of the different estrogen. And once again, if the separation is not perfect, you are specific with the MS. So no problem to make accurate quantification. Here we show you also the optimized condition for the MS base, for the MS when you analyze densylated forms. Here you have the optimized transition, and same for when implementing pyridine. Here you have the optimized condition, and here you have the optimized transition. So once again, if you want to implement at lab, it will be easy for you. Here, some pictures showing you the sensitivity we have with the distillation approach. Here you have different compounds, and here you have the level in terms of picogram injected. And here, once again, I will have a focus on 17-alpha ethinylestradiol, which is our critical point. Here you have an example of chromatogram. We have when injected 0.3 picogram in the systems, and you see that we have really high signal to noise ratio. So we are really sensitive, and it really could make the difference. Here you have the same picture in the calibration curve showing you what is a signal at an equivalent of 1/3 of the new EQS. Here you have the 70-alpha ethinylestradiol, and here you have the internal standard. And here you see that at 1 picogram injected, we are still good on our transition quantification and also for the confirmation. Here you have the same picture with a matrix, a complex matrix, which is an Evian water with DOC level at 1 milligram per liter. And once again, it has been spiked before all the analytical process at 1/3 of the new EQS. And here you see the chromatogram. The zoom is not perfect, but we can quantify. We have the confirmation of the identity of the substances, and we have a reliable quantification at this so low level. But we have to be honest with you, and even with this condition, when we go in more complex matrix, here we are with high level of DOC. The method is not perfect. Here we have significant matrix effects, both with our internal standard and both with our compounds. So we have here a method that is in capabilities to be able to quantify the 1/3 of the new QS, but not in every condition. And even if we have implemented a strong purification step, is not enough. So really, purification step is not an option. And even here, in this condition, we need to still work to optimize the purification. Here, example of chromatogram with the pyridine approach. Here you have different chromatogram obtained with different matrices. And here, what are the key messages we want to show with you? SPM cause clear, barely acceptable interference of the quantifier ion at LOQ level. So it means that really we are totally honest with you. We do not want to give you, we want to be honest. Everything is not perfect. We have achievement, but everything is not perfect, and we want to be honest. Evian and Lock water with DOC, we do not have any issue, even at high level of DOC, which is very important information. And the quantification seems to have been selected correctly because it provides combination of highest sensitivity, and there's no interference in natural, even with natural samples. So this strategy is also a relevant one to improve the sensitivity if needed. And here we have some more example on ethinylestradiol and showing you that it's match. It's okay also. So here, what are our key message? It's not exhaustive, but first set of key message. Change of pre-filter and pre-colon between each round of analysis is our recommendation. And having a very cautious cleaning of the system is really the basis. Rinsing the chromatographic column after each set of analyses with 90% of organic phase and 10% of aqueous phase is really a recommendation. Changes the mobile phase regularly, and in preventing, really not waiting, preventing it is really also our key message. It should be really optimized cautiously, and you really have to take care of that. Ultra pure water quality should be cautiously selected and monitored, and it can have strong impact of the background if if you do not take it into account. Blank injection, you should also introduce blank injection at least between each sample, and some of us has been obliged to introduce 2 blank samples when we want to really go down to the lowest concentration when working with complex matrices. And standard flushing of the injection needle with methanol is also important to limit the risk of cross-contamination within your sequence. What to do to have good performance? Careful optimization of FMS condition, careful and precise optimization of chromatographic separation. Track cross-contamination really is not something that should be underestimated when you want to tackle this low level of concentration. Use high-quality criteria to have robust measurements and robust quantification of these estrogens. Internal standard is definitively not an option in our sense, and be aware of the importance of sample prep, especially the purification. This is the key message for LCMS-MS. In the project, we have also investigating the potencies of high-resolution mass spectrometry with respect to the quantification of estrogens. We have investigating both technology, both TOF and both Q-exactive orbitrap approaches. I will not go so in depth in the detail of the optimization. The separation could be easily achieved implementing the same strategies as for LC1. I will not go in depth with the optimization of the MS. Here you have the optimized one, and you can implement at home. We have also tested free and unselected approach with orbitrap. And what our conclusion, and it is in fact the only key message we would like to share with you, HRMS, in our sense, is not the solution to overpass. Really, the best strategy to robust LOQ is triple quad approach. This is our background experience within the project. HRMS is not the solution if you want to tackle the lowest concentration. The selectivity and it's not sufficient to overpass the limit. Triple quad are really the best strategic approach to have this so low level of concentration achieved. So now I will let the floor to my colleague Anna Kovacic. We will present you all the GC achievement we have achieved in the project. So I'll let her the floor, and thank you for your attention, and we will have time for discussion at the end of this long session.
Thank you for the introduction, Sophie. I will share the screen. Can you see the PPT in the presentation mode?
Yes, it's okay, Anna. Perfect.
Okay, thank you. So as already mentioned, an alternative to LCMS, GCMS can be also used for the analysis of estrogens in water samples. And thus we also developed and optimized the GCMS for the determination of estrogens in a whole water sample, considering also different compatibilities of laboratories and also different purposes of measurements. We optimized the GC parameters and the MS parameters, including volume of injection, temperature program, transitions, collision energy, and dwell time. And compared to the LC, one additional step is needed, namely the dividization of native and labeled estrogens, since estrogens are not high volatile enough to be analyzed directly with GC. We first tested different diuretization agents, all based on the acylation of the compounds, also with different combinations with solvents at lower and higher temperature. And the results were, the responses were there then normalized using diazepam, which is the compound that does not need to be derivatized. The graph is showing the ratio of the average response of the compound at specific condition divided by the average response of the compound in total conditions versus the diuretization condition. And based on the results, we selected two most optimal diuretization agents and solvent regarding in favor to EE2, which has the lowest EQS. Namely, MSTFA with ethyl acetate and TMSI with pyridine were selected as the two most optimal diuretization agents, and they were further tested at different temperatures and time. TMSI with pyridine resulted as the best selection at the highest temperature, while the diuretization time did not seem to affect the process that much. However, we select 1 hour is also a convenient time for the routine analysis. Next, we also check for the stability of these derivatized extracts during the analysis. For this purpose, we tested different temperature, room and -20 degrees within 7 days. And the results show that native and as well labeled estrogens are stable during the analysis with less than 15% of variation compared to the initial concentration. We also tested what the best to find the best optimal injection volume of the sample, and since the highest considered volume with that kind of extracts, namely TMSI with pyridine, is 2.3 microliter. We tested 1 and 2 microliter, and we achieved we obtained nicer peak shape and higher intensity when injecting 2 microliter, and also keeping in mind that we want to get the lowest limit of quantification. This was then also selected in our final method. Here it's just another example confirming this observation, for the example for the 17 beta estradiol. In this table, you can just find the final optimal information, and apart from action volume, we also optimized the sample volume again to get the lowest limit of quantification. We want to find which is the lowest possible volume, and this resulted in 50 microliters. The method was rather fast. The total runtime took 12 minutes and consists of 5 windows, namely 1 window per native estrogen with transitions and with corresponding labeled estrogens. And with this, we achieved the sensitivity and selectivity. Transitions were selected based on area, intensity, and signal-to-noise ratio. First, they were checked analyzing clear, pure standard solution. And the first list of potentially interesting transitions were then further tested analyzing real water sample as well as more complex synthetic matrix. And with this, we wanted to check the impact of the matrix in terms of sensitivity and selectivity. Again, here is only table with our final MS optimized parameters. We noticed that when we analyze the real water sample, we get the interference coelution for some transitions, and then those transitions were excluded or replaced, very similar as already mentioned and observed in case of LCMS. And here again in the table, they are presented then the final selected optimized transitions, 3 for the native estrogens and 2 for the labeled one. We also tested the matrix effect with low and high complex matrices, namely Evian with 1 milligram per liter DOC and Evian with 7 milligram per liter DOC and SPM at 2 different concentration levels, LOQ and 10 times the LOQ. And we can observe that there was no significant matrix effect, for example, for E1, beta estradiol, and as well for EE2, confirming the robustness of the GCMS methods in terms of matrix complexity. To conclude, for GCMS-MS, the targeted LOQ can be reached for alpha estradiol and beta estradiol and E1, but not for EE2 and E3. What to do to have the good performance similar to LCMS, importance of sample preparation, especially purification, optimization of chromatographic separation and MS condition, check cause contamination, and use internal standard for purification, and of course also optimize the debridization conditions. We also developed and optimized the GC high resolution mass spectrometry for the analysis of estrogens in whole water samples. Here are again some final parameters of the method using QTOF as the MS analyzer. The results show the same chromatographic separation, a shift with the high resolution compared to low resolution with comparable sensitivity. However, for the routine laboratories, the issue could be the cost, since the high resolution mass instrumentation is much more expensive compared to the low resolution instrumentation. And with this, I would like to conclude, and we are open for questions. Thank you.
So we have a long presentation addressing many issues. Are there points you would like to discuss? Perhaps some of you would like to share their experience, possibly about the topic of the advantages or disadvantages of HRMS compared to a triple quadruple approach. In our project, we did not see any advantages in terms of improving the sensitivity of the final method, but perhaps some of you have different feedback to share with us. So if there's no question, it means we are so clear, and all the things we are talking and mentioning are all...
We have one question during the presentation, but I think that at the end of the presentation, maybe we have the response of the question. The question is, the robotic chromatogram are referred to HRMS or low RMS?
Okay, so did you have the answer? I'm sorry for the background. I think that you have the answer. We have investigated both. It's true that many of us strongly investigated the MS approach compared to HRMS, but I think now you have the information. Many of the examples we detailed were for MS approach. Are there other points you would like to ask us about our development and on LC or GC approach? Do you share this feeling for those of you we have experience in I would say ultra-trace measurements of estrogens? Do you also experience this issue about quality of mobile phase and issue on selectivity of the transition and so on? Well, you do not help me too much. Huh? Okay, so.
Great. Sorry. I want to ask if it's possible to consider a future SPA offline coupled with SPA online to improve the SPA offline coupled with SPA online in order to improve the LQ sensitivity.
So here your question is not specific to the instrumentation. It's a more global question about the I would say measurement strategy. And if I did not hear you so good, so I have to be honest. You asked about the difference or the relevance about SP online with respect to SP offline.
No, the question is if it's possible to incorporate the SP offline with SP online in the same.
Okay. I see the point. We have not investigated this strategy in the project, but so I will be in trouble to answer to you on the basis of, I would say, background and really technical and knowledge, experimental knowledge. But I think that it has been performed, and I think that I read some equivalent strategy in some publication. But in the project, we did not investigate this strategy. But I do not know, perhaps you have some experience in your lab, or perhaps some of you in the audience have tried this strategy. I would say successful, sorry for my lack of English this morning. Perhaps some of you have tried this strategy, SP offline plus SP online, allowing a bigger volume of injection and after LC MSMS measurements. But the risk is, once again, is still the risk of the impact of the matrix if you do not have purification. If your SPE online is really orthogonal in terms of I would say type of chemistry, perhaps it could be very, very powerful. But if you do not have any purification of the extract, my fear is that you still will in trouble with so much matrix effects or problems of background, and that will not allow you to go in the lowest level. But it is my feeling, once again, not based on scientific or results. It is a feeling. I think it could work if the strategy are orthogonal in terms of chemistry. I do not know if someone has something to say about that.
I have some experience, but the LQ is 0.055 nanogram per liter, not 0.005 nanogram per liter.
Yes. Okay. So, and which kind of sorbents did you use in your two-step approach?
For LSC analysis or for SP emission?
For the SP. For the extraction, and then after for the SP online, what was your
for extraction in the final step? I use methanol, and for LSC a mixture of water with acetylnitrile with ammonia.
Okay.
Ammonia sulfur.
And concerning the sorbent for the extraction, the chemistry of the extraction phase are separate. What were the when you perform the extraction? On which type? Were you on C18, HLB? So the microphone is closed. So if you answer to my question, I don't hear you. We don't hear you.
Sorry, do you see?
No,
okay,
hear you.
I use the hydrophobic lipophilic phase for extraction.
Okay. Thank you. Yes, so it could be a strategy, but we have not investigated this strategy in the project. So we are early in the agenda. because we saw that there will be more discussion in these important topics of the instrumental development and so on. So I will once again ask the question to the audience. Either we have a coffee break now, and we come back at 10:15. Either we go for the presentation on the MS equipment, but it will be a long one. I prefer to tell you. So up to the audience, what is the best strategy? Either we have a coffee break now, or we go on.
Maybe a coffee break now and then go back at 10:30.
10:30, so you want to have a 30 minutes coffee break?
As you want.
If the audience is okay, it's okay for me.
I don't know, there is no remarks on the chat.
Okay, so we make a coffee break, but 30 minutes is a long time, perhaps 20 minutes.
Or 15 if you want.
Sorry?
Or 15.
Yes, 10:15 if it's okay for everybody. So we go back in 15 minutes to have the second part of this session.
Okay.
So, okay. Coffee break.
Salut Sophie.
Bonjour.
Salut. Ça va?
Ça va et vous?
Tu nous vois?
Très bien. Oui, je vous vois.
Ah, ok.
Je vois Maglone et je te vois Véronique avec une chemise bleue.
Non, on a squatté son bureau parce que...
Ah bah oui, bah c'est infernal. Hein. Bah, c'est pour ça que je suis là.
Ici, hein.
Infernal.
C'est la catastrophe.
Hier, Béatrice nous a mis dans ton bureau, mais non.
Non, c'est pas une bonne idée.
Heureusement que t'es pas venue, Sophie.
Ah ouais, parce que là, la présentation, ça aurait été sympa.
C'est juste une horreur. Alors, déjà, moi, je suis sourde, mais alors avec le marteau-piqueur, je n'entendais plus rien.
Bah, c'est pour ça que je suis à la maison. Je voulais pas le faire ici au départ, mais quand j'ai vu lundi, je me suis dit là c'est pas possible. En plus, je parle beaucoup trop. Enfin, c'est pas comme si je parlais 5 minutes, quoi. Mais là,
voilà.
C'est ça, j'allais dire. Là, tu parles déjà pas mal. Donc,
tu parles beaucoup déjà et c'est vraiment super. Hein. Ça présente. Ah ben si.
Il y a tout le monde qui nous entend, donc on va peut-être pas faire le débrief. On en parlera demain.
Ah, allez, demain tu es là. Ok, ça marche. Allez, on coupe alors. Ciao.
So coffee break time is now close to be finished, so I suggest that we will start with the next part of this session, where we will present you the achievement of mass spectrometry-based method performances, and method reliability. I hope you are all back, so I suggest that we start. So let's go. First, as a reminder, quality and comparability of data rely on the respect of three pillars. First, metrological traceability to the SI. Second, accuracy of measurements. Last, estimation of measurements uncertainty. So within this presentation, we will present you many things around these three pillars that are mandatory to have high quality measurements. First, let's go to basic. Metrology traceability, why it is so important? Because it gives you confidence and assurance that your measurement results are right. And here you have this famous picture of what is, in fact, traceability. It is a non-break chain of measurement where each of them are traceable to this unit, SC unit. Here, because we are in a research project focusing on metrology and involving NMI, we are developing these primary calibrator and reference measurement procedures to allow all the others to be related, and to allow that the final users and all the laboratories are traceable in this, by this way. So in the project, once again, a key reminder about the BIPM, which is the key pillar international organization that manage all the issue of traceability, and that provide you a definition which is part of the international vocabulary of basic and general terms in metrology, which is also called VIM, and which define metrological traceability as a property of a measurement result whereby the results can be related to a reference through a documented unbroken chain of calibrations, each contributing to the measurement's uncertainty. So it is a definition of the picture that I showed you just before. Metrological traceability is also a key pillar of the ISO 17025, and here we put the extract of this standard. So first, laboratory shall establish and maintain metrological traceability of its measurements results by means of a documented unbroken chain of calibration, each contributing to the measurement uncertainty, linking them to an appropriate reference. So this is really the pure and intrinsic definition of what is metrological traceability. And it also mentions that the laboratory shall ensure that measurement results are traceable to the International System of Units, SI, through calibration provided by a competent laboratory, certified value of certified reference material provided by a competent producer with stated metrological traceability to the SI, or direct realization of the SC units ensured by comparison directly or indirectly with national or international standards. So within third point, when metrological traceability to the SI unit is not technically possible, the laboratory shall demonstrate metrological traceability to an appropriate reference, which could be a certified value of certified reference material provided by a competent producer, or result of a reference measurement procedure, specified method or consensus standards that are clearly described and accepted as providing measurement results fit for their intended use and ensured by suitable comparison. Just reminders, so traceability, you have to define the measurement. It could be an operationally defined method dependent or structurally defined method independent. And traceability is also linked to amount, so a value plus as an uncertainty associated to this value that should be linked to a reference could be a SC units or a human-made artifact. Still some definition, but some of this one are really important. What is a reference material? It is a material sufficiently homogeneous and stable with respect to one or more specified properties, which has been established to be fit for its intended use in a measurement process. Properties can be quantitative or qualitative, and as instance, when it's qualitative, it's an identity of a substantial species. And what is a certified reference material? It is a reference material characterized by a metrologically valid procedure for one or more specified properties, accompanied by a RM certificate that provides the value of the specified properties, its associated uncertainty, and a statement of metrological traceability. So one key message is, it is not because a material is sold with a certificate that it is a certified reference material. The key difference is the metrology valid procedure and the traceability to the SI. It is a big difference. So because there's a lack of certified reference material to establish traceability, there's only one available for 17 beta estradiol at the beginning of the project. We have developed within the project 5 CRMs to cover all the different targeted substances of the project as pure standard, as solid one, that could be used for the validation, that could be used for interlaboratory comparison, and as artifacts could become commercially available after the end of our project. So meaning that there will be commercially available tools, metrological tools, to establish traceability to SI of all measurements, which is a key pillar, and to establish the comparability of the measurements. Do you have some question about this issue of traceability? Key concept and needs and importance of that in your development or validation?
Hi, he's Sebastian Buchinger, Federal Institute Hydrology. It's more a practical questions. Perhaps we come back later to this when we talk about the trial. My question would be, so you have put some effort in defining these reference materials. So at the moment we, let's say just buy a vial of EE2 by Sigma or something like this, but this would be not a traceable reference material as you define it. Could we get access to such a traceable reference material for the trial from you, or where do we get it?
I suggest that we keep this point for the discussion. We will answer to your question.
Great, thank you.
Thank you. So if there's no more question about traceability, I suggest that we go up and to discuss about method validation. What are we talking about? Validation, as defined by the VIM, is the verification where the specified requirements are adequate for an intended use. This fitness for purpose should be demonstrated through experimental and well-documented evidence. Experiment design philosophy. What has been our philosophy? It summarizes the in-house validation strategy for the MS methods and EBM optimized within the project, and all the partners will validate their methods in accordance with CNTS 16800 standards that has been published recently. The scope of each method will describe the measurements, the matrices, and their application range. Common design for all the partners has been implemented to allow us a minimum basis to compare the method we have developed in each of our lab. It will be methodologically robust and sustainable. So our strategy, method validation, we are at the within laboratory level. So first level of the SEN standard. So what reference have we implemented? We have followed for the identification ISO 22531 as a first pillar. We have determined the performance characteristic of our method according to SEN TS 17800. And we have also estimated our uncertainty implementing two approaches. The one of the ISO 11352 and the GUM approach. And the GUM approach, I would say, is more dedicated to the NMI. And as we are NMI, we should implement them to demonstrate that the method we are developing could become reference method. And with respect to the intended scope, here what was also, and I will only focus on MS-based method. So our measurements are estron, 17-alpha estradiol, 17-beta estradiol, 17-alpha-18 estradiol, and estriol. The unit is a microgram per liter. The matrix, what were our scope? Surface water and groundwater at first, and some partner has also tried to investigate drinking water and marine water. Matrix characteristic, well water, and we have demonstrated the validation, the full validation of the method until 50 milligram per liter of PM and a minimum level of DOC up to 7 milligram per liter. And our concentration range cover the need, 1/3 of the EQS to 10 nanogram per liter. What are the performance characteristics we have addressed? Calibration range, verified quantification limit, selectivity, sensitivity, bias, method recovery, absolute and relative, precision, repeatability and intermediate precision in considering days and operators, and of course, measurement uncertainty. Just an important definition, what is a verified limit of quantification? It is it has been experimentally verified under an intermediate precision condition of the estimated LOQ. It is really critical. So to establish this verified LOQ, you have a pre-estimation and then you confirm in intermediate precision with the implementation of an accepted accuracy that you should define at first. And within the project, we have set this maximum accepted accuracy to 60% at the LOQ. So a small message for the French laboratories that are there, we are complying with our French standards. I close this small message. So this is the choice we have made, and all partners follow these rules. As you can imagine, the choice of the matrix selection is something important to demonstrate the fitness for purpose of the method with respect to this intended use. So once again, some few definition. What is an influence parameter? It is an intrinsic characteristic of the matrix, independent of the analyte concentration, of which is able to modify the analytical results. What is a representative matrix? It is a sample for which all these intrinsic characteristics are characteristic of a type of water of the source or a group of samples. And representative validation matrix, which is of course what we need to discuss, it is assess probable analytical performance with respect to other matrices or for matrix match calibration in the analysis of broadly similar commodities. Just to this definition, reminder for many of you, because they are really critical when making this validation step. And they should be aligned with the intended scope. So what are our type of waters? inland surface water, groundwaters, drinking waters. And what are the influence parameters we have based on our knowledge, background experience in the optimization and development of the method? For us, our key parameters were SPM content, organic content as dissolved organic carbon content, ionic strength, chlorine for tap water, and we do not consider pH as a significant parameter. Ionic strength, yes, not pH. So now, key issue, displaying of natural representative blank matrix and how to manage that in a project involving 8 partners coming from different countries with, furthermore, this COVID context, which have drastically impact all the synergy within the project, because we were all facing COVID issue in different time, because there was this wave, and the wave came from the east and then go to the west, so we were in trouble. So we have been obliged in the project to find a sustainable strategy. So we will show you what was our strategy. So to overpass all this issue, we have made the choice. So it is mandatory to have 6 different matrices to make the validation according to have the sufficient number of data to make the data treatment. And so this is our choice. We have chosen 3 common synthetic representative matrices. First one, Evian water plus DOC at a level of 1 milligram per liter. So I would say a low complex matrix. Evian water plus DOC at 7 milligram per liter, and Evian water plus DOC at 7 milligram per liter, and SPM at 50 milligram per liter. So this is the strong basis which will allow us really to strictly compare the performance of the different methods developed by the different partners, because we will all have the same matrix in each lab. And furthermore, each lab were free to choose 3 represent matrix at its convenience, synthetic or natural. And here you have the panel of all the different type of matrices that has been tested by the different partners, with some were natural, some were only synthetic, with different ionic strengths, different organic carbon content, with different SPM content. And just to show you that we have covered really a huge range of matrices within the project, and not necessarily the easy one. As you see, some partners tested DOC level up to 40 milligram per liters. So it's not really an easy matrices. So this is the view. So just a summary, our method validation experimental design was 6 matrices, 3 common plus 3 customized. All these analyses were made in intermediate precision condition. 3 levels of concentration were tested for each matrices, LOQ, 3 LOQ, 10 LOQ. All the analyses were made in triplicates. We investigate the matrix effects only at 1 level, which was the mid one, 3 LOQ. The recovery, absolute and relative, were also determined at the 1 level, the intermediate one, so 3 LOQ. And we perform 6 independent calibration in intermediate precision conditions. This is the broad scope of the validation, and you can see that it implies a significant number of samples and a significant volume of samples. So we are at hundreds, in total, more hundreds level of samples. So it was definitively not possible to manage so big batch of sample in the project. So this is why we have chosen this strategy. Each lab is independent from the others. Do you have questions or comments about first the strategy of the validation? Because perhaps some concepts are new from some of you. Do you have feedback or perhaps comments on this strategy? Our purpose was really to operate not as research laboratory, but really to be faced to the same issues that routine laboratories that have to have accreditation and clue and elements and proof to accreditation body. So we really go in that strategy for that. We need to comply to the same rules than routine laboratories. I do not see if there's question of comments.
At this time, we have no comments or question on the chat.
Okay. So let's go now to discuss about the results. First point, how to find a blank matrix to make this validation. We, at the beginning of the project, did not anticipate it, that we will have so many trouble to find free matrix. And it has really a big issue in the project. So, of course, I will show you some small picture about that. Here you have a representation. You will have different, but all of them will be based on the same philosophy. You have the ratio of the blank on the targeted concentration, TC. Here it is an example for two substances, 17 beta estradiol, 17 alpha estradiol for one lab. And here you have the different matrices that were tested, and here the different concentration. LOQ, 3 LOQ, 10 LOQ, and each time it will be the same. And here you have the information about the targeted concentration. And you see that, of course, and it is always the same, it is not a problem when you have to face the validation at higher level. But when you go down, it becomes critical. And at the end, it is really tremendous, and you do not, it's really difficult to overpass the issue to find blank matrices to make the validation, because of course when you make this validation and you estimate your limit of quantification, you are not allowed to subtract the background, because if you subtract the background, you do not demonstrate the same thing. You demonstrate that you are in capability to accurately measure an amount equivalent to the targeted LOQ, but you do not demonstrate that you are intrinsically capable to quantify this LOQ. It is a big difference. So it is really tremendous. And we have many issues in the project to fully demonstrate the performance of our method. This is a first example from one lab. This is a second example from another lab. The metrics were different, of course. But here again, you see that at the lowest level, we have some difficulties to overpass this issue of finding blank matrices without any significant background inside. Once again, the same example. So this is really critical when you have to demonstrate the performance of the method for this compound. This is also why it legitimates the choice of working with synthetic water design at lab. This is a very good reason to do with this strategy. Do you have question or experience to share with this issue of how to validate a method when you do not find real blank matrix representative or your intended scope? How do you solve them? Did you have experience on that? Here, I think we have a broader view, because the view comes from 7 different partners from different countries working on different conditions and so on, and we all face the same issue when we go to the lowest concentration. So we do not have any laboratories that have experienced such issue. Perhaps you have other strategy for validation. Perhaps also it is the reason why you did not experience such kind of issue.
I have no remarks or question on the chat.
Okay, so we will go on, but really for those of you who want to make this validation in real matrices, be prepared to be faced with such kind of issue if you tackle the lowest concentration, of course. Matrix effects. Just a picture just to show you. So here it is a representation of the matrix effects we have observed in the more complex matrix, the more complex matrix we have in the project. This is a common one. So DOC with 7 milligram per liter and SPM 50 milligram per liter, and you have a color code. It will be the same for all the presentation. So for each method that has been validated by each partner, and you see here something very interesting that. Remember yesterday when we present you the purification with MISP, here we confirm that when implementing these MISP purification approaches, you have really a decrease of the matrix effect, even compared with the other LC-MS approach that nevertheless implement purification, but the purification is less powerful, I would say. And what is really interesting also is to see that the level of matrix effect are become quite comparable to those of GC-MS. So this is very interesting. The result also demonstrates that GC-MS is definitely more robust to matrix effects compared to LC-MS, even if we implement all purification. And nevertheless, what is globally the good picture is that the level of the matrix effects are under control. Here it is an artifact. We had a problem in the measurement, but we nevertheless keep it on the slide. But we have normally less matrix effects with these approaches. But we do not want to manipulate the data. The data is the data. We assume it, but we can inform that usually we are not facing so many matrix effects with this method. So here, yes, purification put you in good condition. Nevertheless, you have, I would say, reasonable matrix effects even at highest complexity of matrices. Now let's go to recovery. So in the project, we have evaluated both absolute and relative recoveries because we feel that both are highly important to be under control and also to achieve the most sensitive, the better LOQ, and also the more accurate method, and to have also the uncertainty under control. So here, once again, you have each method with this color code. You have the different, you have the definition of the different techniques, and you have here the absolute recovery, and here you have the relative recovery. And what you can see is that the absolute recovery are all over 50%, whatever the type of matrix and method. And we see that IDMS really compensate and is really a suitable strategy to reliable measurement. This is a picture for estriol. The picture is the same and even better for estrone. Here you have the one for 70 alpha ethinyl estradiol. The dispersion of the results is, I would say, greater. The evidence of the importance of the isotope dilution is perhaps less evident, but let me tell you that it is nevertheless really critical, and we assume that the dispersion is also linked to the level of the concentration where we are tackling. We are lowest than the others. Here, the same picture for 70 alpha estradiol, and the last one for 17 beta estradiol. So once again, key message, IDMS is really key to have reliable measurements, and purification step is really key to have under control matrix effects. So this, on these 2 points, do you have questions, remarks?
It seems to be no remarks or question.
Are you still there? Did I kill you? I hope not. So I will pursue. I hope I am not alone to speak, to be there. So uncertainties. So here, once again, it's not the full result of the project. We will you will have them after we will have some publication, and we are in the fair data process, so everything will be put available to the community. Just here a picture. It is the relative expanded uncertainty at a level of 0.91 nanogram per liter, which was more or less a common level where all the different methods were performing, with the exception of the GC-MSMS method. It has been shown you before by Anna, my colleague Anna Kovac. It is a little bit performing at this level, but that does not mean that it's not a significant strategy to be implemented. So here, this is a picture. We wanted to show you the uncertainty at the common level of the same level of concentration for all the different methods. Here again, the color code, you have the the different strategies that has been implemented. And you can see here that the expanded uncertainties in the intermediate condition following ISO 11352 guidance are under control, less than 50% for many of the method. And here for this lab, once again, we did not scratch any data. There was an interfering compound. We know what has happened, but at this stage, we did not scratch it. But we want to be honest with you. It's not, everything is not magic. We do not have, we are not, we have some trouble as everybody. Sometimes something happens. We do not want to scratch the data. But of course, the method is, when we made the new measurements and so on, and we can tell you that the level of performance of the method is comparable to the others. So yes, but it was just by transparency. We let the data as they are. Now let's go to the accuracy and the issue of the LOQ. So just to remind, the LOQ in the project has been determined by a maximum acceptable accuracy of 60%. So what are first achievement, what key message? Concerning GC-MSMS, the LOQ are highest compared to LC-MSMS, but the robustness towards matrix effect is more important. And we can also, we have the feeling that with new generation GC-MSMS, we can significantly improve the LOQ. So really our message is GC-MSMS should not be scratched. It is really a relevant strategy to make reliable quantification in the environment. Method based on HRMS, either coupled to GC or LC, do not increase the sensitivity and will not solve the issue of the WFD requirements. All the methods developed by LC-MSMS reach LOQ close or at least of 0.9 nanogram per liter with a maximum EMR set at 60%. And some of the developed methods have the potencies to tackle new EQS and 1/3 of the new EQS for 17 alpha-18 estradiol, which is, of course, as you all know, the most critical parameter. And now I will show you some picture of what are our achievements. Sorry. So here I will detail in how it is built. It is a kind of profile of accuracy. So here you have the mean of the measurements and the dispersion. Here you have the targeted value, the TC value for this laboratory. Here you have the plot of the EMR. So here at the LOQ, it was set for all the partners at 60%, and after partners could design the accepted EMR depending on their choice. So here you have the plot LOQ, 3 LOQ, 10 LOQ, and here you have the picture of the concentration. It is for one method based on SPE, NHD, NH2 purification, and LC-MSMS. And here you have the accuracy profile for 18 estradiol. And here you have the value of this value is equivalent to the new EQS. And here you have the 1/3 of the new EQS. And what you can see is that this method is in capabilities to tackle the 1/3 new EQS. So it is successful. This is a picture for alpha estradiol. Once again, good. The same for beta estradiol. The same for estrone. And here, estriol. This method is less robust to make estriol measurement than to make ethinylestradiol one. So it is interesting to know. It is linked to some interferences observed in some matrices and the lack of selectivities of some transition. So we come back to some previously discussion of today. This is really something critical and it should be considered. But nevertheless, even if this method is less performing at the LOQ, the performance at upper level are quite consistent. And estriol, we do not have EQS. It is not mandatory, so the level of concentration should be set at convenience. So this is the reason why we overpass this, and we could assume that this method is fit for purpose for WFD monitoring. Once more, we would like to show you and demonstrate. It is a picture, in fact, that support my my talk just before. Here we have taken the liberty to subtract blend, even if it's not allowed in theory, but it's just to show you that, in fact, it's just a question of, we do not find a matrix without background. It's only, once again, the problem of finding blank matrices. So, in fact, in theory, the method is totally okay. So we switch to another method based on SPDISC, NH2 purification, LC-MS. Once again, still the same picture. It's okay for estriol. It's okay for alpha estradiol. It's okay for beta estradiol. It's okay for estrone. Problem. It's not so okay for ethinyl estradiol. Here we overpass the maximum tolerance for the LOQ. We are upper, and here we are not so good at 10 LOQ, but we have an explanation. It's linked to a contamination. We have identified the problem, but we did not scratch the data. We have kept them because we want to be transparent. We also had some problems. So still the same message. Everything should be under control, and we have made a mistake. And since we have made new measurements, and we can tell you that at 10 LOQ, our method is definitely performing at respecting an EMA of 30%. So here, this is the level of the new EQS. So our method is capable to quantify new EQS, but not at 60%, but with an EMA of 80%. But once again, our problem was we did not find matrice without significant background. And once again, if we delete the matrix where we have significant backgrounds, that's to say background which are upper of 60% of our spike, yes, here we are okay. We respect the EMA, and when we scratch the bad data where we have a contamination, of course, our method is totally okay. So this method is, once again, has the potencies to be used. It has the potencies. We have made in this lab 2 approaches, and we have implemented densillation. And when we implement densillation, we have a method that is capable to reach 1/3 of the new EQS, and demonstrating that with these approaches, you can overpass the limitation of the lack of ionization with common approach. But with this method, we have some problem with high level content matrices, those who are we have high content in terms of DOC. So if you remember, we show you the picture of the chromatogram just before when we have 100% extraction of signal. So here again, we have a method which has the potencies to reach 1/3 EQS, but with a restrictive scope of application. And here, if you remember the picture we show you, more than 80% of the matrices in Europe have DOC, median DOC level close to 3 milligrams per liter. So it means that this method could also be implemented in the majority of conditions. This was some picture, not all, because it was not possible to show all the result of the partners, but just to show you that we have significant improvement of the methods due to the work we have underpinned in this project. I hope we have convinced you on that. I do not know if some of you have questions about the accuracy profile and uncertainty and what we have demonstrated there. We have made the choice also to be totally honest. We have also some problems as all laboratories, and it was a choice to not to mask this problem. We have to deal with that, and it's honest. We wanted to be honest with you. We have also, everything is not 100% under control. So if there's no comments.
No question, no comments.
Okay. So recommendation, gold standard and good practice. What is our conclusion? Ultra-3 estrogen measurements below 0.1 nanogram per liter is a new dimension, and every detail counts. Many of the partners have experience in ultra-3 measurements of pHs, of PVDs. Many of us have yet, at the beginning of the project, experience in estrogen measurements, but not at this so low level of concentration. And we have been very, very surprised of the so many difficulties we have been obliged to overpass. But we have found solution, and this is what we would like to share with you now. Some general remarks. You need really to have advanced chemists and operators if you want to have these measurements under control. You have possibly the need to dedicate material to estrogen measurements, and including the instrumentation. We have some bad experience in the project when switching the instrumentation to other thematics. When you come back, you have really to have strong cleaning of the initial performances. So yes, it could imply to dedicate systems for these measurements. Glassware should be preferred to any other type of raw material. This is our view. Cleaning with detergent, solvent, calcination should be implemented. And you have also to shorten the time of storage before uses to prevent from contamination of the environment. Every detail counts. Caution has to be paid with reusable material, as it could increase risk of cross-contamination and losses due to sorption when you reuse material, especially. Solvents, including laboratory water, even high purity water, could be a problem because of interferences and should be checked regularly. And we recommend also gravimetric control of all the operation to be sure to be robust and reliable. We are dealing with so low level of concentration. Everything should be under control. 17 alpha estradiol should be introduced in the method. Really, otherwise there are risks of bad quantification. IDMS for us is totally mandatory if you want to have reliable quantification. And we furthermore recommend the inclusion of tracer for the instrumental part to monitor your internal standard for quantification. Validation. And we said real validation in a real representative matrices should be the reference approach. There's too many issues and differences when making this validation in, I would say, clean condition, easy condition, and what happens in real life. Really, it is really important. Validation based on defined EMI should be preferred to signal-to-noise approach as being really more robust and really more representative of routine operational condition. QAQC approach should be rigorous and implemented to cover the overall procedure. Method blank should be systematically implemented in each series. Instrumental blank should be included in each run to prevent cross-contamination. Positive quality control at the LOQ should be included in each series to attest of the efficiency of the sample prep. Positive quality control at the instrumental quantification limit and or LOQ should be included in each run to attest on the intrinsic sensitivity of the instrument and also the absence of drift during the runs. Here, this is our view of what could be the golden way to make these so low level measurements of estrogens. SP cartridge could be relevant, but not when you go to high complex matrix. And with the feedback of the project, up to 50 milligram per liter of SPM and up to 7 milligram per liter of dissolved organic compounds. We have, when you have in this so complex condition, when you have this 50 milligram per liter, you can have high risk of clogging and bad experience within the project. We do not recommend to increase the volume of intake up to 200 milliliter. You can, of course, implement SPDISC on, I would say, a huge as a most robust approach, especially if you anticipate you will face high content of SPM and high content on DOC. And you can also increase the sample intake up to 2 liters because we have some data showing that you do not have impact on the extraction. But of course, you have to manage the risk of matrix effects. It is always a compromise. Isotope dilution and equilibrium time of minimum 12 hours, especially in matrix with high complexity, is really our recommendation. Implementation of purification. In the lab, in our project, we have investigating both strategy, MISP and LC and H2. Other could be relevant, but purification should be implemented. And LC-MS-MS is the most as our favor at this stage of mastery, implementing or not derivatization strategy. Concerning LC-MS-MS, really implementation of pre-filter and guard column is recommended. Dedication of instrument is also a recommendation. Rigorous preventing cleaning should be implementing. Automatic integration should be used with caution because we have had some problem in the project also at this automatization of process, especially when you are in complex matrix at low level. Really, it is really important to check and to make it manually in many times. Otherwise, you have significant impact in the quantification. And it is also a recommendation to avoid multiple injection of the same blank because otherwise you will face some cross-contamination in your process. And with that, I think I close this section on achievement of mass spectrometry method. Our key message on these 2 days, what we have shown to you, all the lessons, we have tried to be honest and share all the things we have developed and our experience. Do you have some question about this last slide? So there's 2 possibilities. You are impressed by our results, or you just feel that it is unuseful. I do not know what to think. I hope this is the first option. Or perhaps you do not think that what we are saying is interesting to you. I will really appreciate to have some feedback, just even putting something with a reaction mode. I do not know, but it's really difficult to have all this camera off and nobody saying anything.
Well, I'm working more in the field of the effect-based methods, but I have a long ago chemical background, so I'm impressed. So I think you did a great job and looked at so many different things, and I think this background issue that you mentioned, of course, it's extremely difficult to find a pure reference matrix. So I think that your way of working with artificial control matrix was a good way. And I just wonder, because you spoke now about the mass spectrometry, the chemical analysis, which of these aspects that you talked about we should take care about if we speak about effect-based methods? So the discussion will come tomorrow, but you do a lot of things, and yeah, I think there should be more exchange, perhaps. Yeah, so just my comment. Thank you.
Thank you, Sebastian. And we could, of course, discuss all these points tomorrow in the specific session on EBM. Because it's clear the issue are different, the objectives are different. We will show you what was our strategy, and I think they could have some nice exchange tomorrow also with respect to this point. So if there's no reaction, nothing more to say, I think we will switch to the last point of this session, which is, we'll talk about the, oh, yes. Okay, thank you for your feedback. So we have a lot of EBM experts today with us. Chemists are welcome you, and see you tomorrow for a nice discussion on EBM. So I think that will be a fruitful discussion tomorrow, but thank you for your comments. So now we will switch to the last point of this session. We will talk about the future and the next steps toward interlaboratory comparison and standardization. So first, we are actually organizing an interlaboratory comparison whose aim is to demonstrate the fitness for purpose of the optimized and validated method in the project, both MS-based method and EBM methods. So for the EBM method, we will go in depth tomorrow, but so perhaps we can keep the question on EBM for tomorrow. It will be more appropriate. This ELC will allow to define performance characteristics of the methods in terms of repeatability within laboratories and reproducibility of the validated method, and support also standardization process. So the time schedule is the following. By the 30th of September, we will send you the protocol. So we have yet, in fact, shared with you many of our protocols, but it will be delivered in order to help you to implement at lab. The dispatch of the material is planned by 2nd November 2022. The involved laboratory will provide the results by 23 of November to a specific address. Yes?
Sophie, do you want to share your screen maybe?
Sorry.
Thank you.
Yes, I thought I've made it. Sorry. No, this is not a good presentation, sorry. I apologize. So
it's not in full screen.
Yes, I'm trying to. I am obliged to go to start a second time. It's a pity. Do you see my screen?
No.
I have the feeling that I will not succeed in sharing my screen in another. I do not want to make you lose too much time. So if
it's okay, not in, yeah, I think it will be okay like this.
Can you read?
Yes.
Okay, I apologize. So I go back. So here the time schedule of this interlaboratory comparison. So by 13, we will deliver to you some protocols to be implemented at lab. By 2nd of November, we will dispatch test material to each laboratory that has been expressed its interest. You will have 3 weeks to make the measurements and provide the results to a specific address that has been created by ISPRA colleagues that are in charge of the organization of this interlaboratory comparison. By 20th of December, we will provide you a preliminary statistical evaluation of the interlaboratory comparison. And by the 15th of February, we will provide you the final report and some, we plan to organize a meeting to discuss about the result of this interlaboratory comparison, because it is important to share and to have a global improvement of all the laboratories that will have to make these routine measurements of estrogens in the near future. So concerning the interlaboratory comparison design, so we will dispatch 2 materials, representative natural waters plus 1 QC as a blank water. We will deliver it as kits to be reconstituted by each laboratories. The kit will be constituted of water, SPM, DOC solution, spike solution, and you will have a written protocol to make, in fact, your own sample at lab. And we will provide a video showing one of our, in fact, the BAM colleagues which are in charge of all that things, showing good practice and how to make it in real to help you to implement at lab. So, for this interlaboratory comparison, we need you, really. We really expect you to take part to this story and to demonstrate that we are going in the good way to improve the general capability within Europe to tackle challenges of estrogens measurements. So we have a new deadline to register, 20th of September. Here you have the link where you can have all the information to register and all the detailed information about the requirements and information that you should provide in a first attempt. And I also remind you here, key colleagues that are in charge of the interlaboratory comparison. They are with us today, of course, and we will be able to have discussion, and they will be able to answer to your question if you have some of them. So it's Paolo De Zorzi from ISPRA, Sabrina Barbizzi from ISPRA, and Timu Naiki from SUKE. So this is the point for the interlaboratory comparison. I really hope that through these 2 days, we have convinced you that it's nice for you to take part to this interlaboratory comparison. You will improve yourself, and it's also it will sustain a standardization process. In fact, if you remember yesterday when I introduced you the project, our key objective is to disseminate all the knowledge of the project to the standardization, and it is yet in the pipe. An official working group has been established at the ISO level. Is working group 84, estrogens using MS-based method. And we are yet in drafting future standards, determination of selected estrogens in whole water samples, method using solid phase extraction, followed by gas chromatography and or liquid chromatography, sorry, I missed one part, coupled to mass spectrometric detection. I will be pleased to be the convener and project leader of this work, and I will have a strong relationship and connection with Jochen Toke from Utah in Germany, because German colleagues are also starting to work on the design of a standard, and we will merge everything to have this huge and so nice ISO standard. So the plan are the following. The working group has been officially installed in beginning of this year, and the standard is going to be published in 2024. So all the things that we'll have learned and that we will learn through this interlaboratory comparison will help to design this future standard that is needed if we want to have comparable, reliable measurements within Europe and worldwide. And with that, I conclude. And I really hope that there will be a nice discussion about the interlaboratory comparison, especially. And I welcome my colleague, Paolo Desorsi, Timo Naiki, and Christian Piecota, which are in charge of this interlaboratory comparison, to jump into the discussion to help me to answer, to manage this discussion. What we could say is we will take all your questions, and if you don't mind, we will wait until the end of this 2-day session, and we will provide you some answer. But we would like to keep also the discussion of tomorrow to have after a concatenation of all the discussion, and we will come back to you by writing to your question just after this training. We will not. Some question could be answered easily during the training. Some will need to have some internal discussion within the consortium. So we will come back to you just after the training. So perhaps we can come back to one of the questions about the establishment of, do we plan to circulate solution to establish the traceability to SI of the measurements? And perhaps I can let you, Paolo, or Christian, or Timo, leading this discussion, if you don't mind, as you are leading the interlaboratory comparison. Perhaps, Paolo, you could take the lead.
Yeah, yes, I am here as Timo and Christian. Please, which is there is a specific question, so probably I jump it or skip it. I don't know. So
we have a question when we talk about traceability. Someone asked us if we plan to deliver solution to establish traceability to SI.
Well, we have to plan that we send the reference material together in two as ampoules to reconstitute together with the bottles of water, and together with SPM and DOC in order to create the test samples for the interlaboratory comparison. And this material, Christian can confirm, will be sent directly from one organizer produced by BAM. So if there is some question about the production of reference material, probably should be better that Christian could reply to specific question about these issues. In any case, each laboratory will receive, as you told us, repeat, a kit, and that they will ask it to reconstitute in the lab the test material, both for EBM methods and for chemical methods. So, please, Christian, I see that you are on the screen. Sorry. Also, I am in the video. Excuse me.
So, as Paul Paolo already mentioned, we will send the samples for the interlaboratory comparison as a kit to the participants, and the kit will consist of common mineral water and different ampoules which containing the synthetic DOC, the suspended particulate matter, and the spiking solutions for the 5 estrogens. And we will also provide a protocol for setting up this reference material in your lab, including also, as Sophie mentioned before, a video where we can show the procedure in detail.
We have one question on the chat, critical question. Which LOQ will be targeted in this exercise?
Well, now we are receiving the interest from the laboratory, and as you know, we asked which are the LOQ for the 5 targeted substances. And obviously, we will tail the protocol and the test material, taking into account also the capabilities, the chemical capabilities of the laboratories, but in also looking at the request from AQS. So this we need to combine these 2 bounds. And at the moment, some laboratories are fully in line with the AQS, other no, but we will test 2 different test materials. So I think that we can manage this situation. At the moment, I from my side, but I know if Chris and Timo or also Sophie would add something, defined exactly the level of concentration we have to discuss. Fixed. Exactly.
We will come to you all interesting participants in the next days or weeks to precise everything, but it's not fixed yet because we have really a challenge to address.
To this end, I would like to underline, highlight again, as Sophie anticipated, the importance of participation. As you know, most of you participate normally, routinely in proficiency tests, but this is in collaborative trials with another objective. We need data, we need results, we need measurement, we need laboratories that participate into the exercise in order to share a useful information to the community. So my words, together with Sophie and the other partners of the consortium, is also to participate and if you can, also to disseminate where within your network where we cannot reach completely and easily.
Sebastian, want to talk?
Yes, Sebastian.
Yeah, thank you. I tried to launch, perhaps here. So now you can see me as well.
Oh, yeah. Nice to see you.
Nice to see you. So thank you for a clarification about the reference material. But I have a further question. When we do a calibration of our measurement, if I understood it correctly, we have to use traceable reference to do the calibration as well, right? But you would not send this pure, let's say, EE2 for us to do the calibration. We have to, so at the moment we just, as I said, we buy by Sigma or somewhere else some material, dissolve it, and this is our calibration. But this would be not acceptable for you, right? And that's and so the question is, where do we get material that is acceptable for you when we do our calibration? Is it clear what I want to know?
Yes, your question is how to have independent solution to demonstrate.
Mm-hmm.
Yes.
Christian, perhaps
Yes.
you
Yeah. So we have the problem that we have only one set of certified reference materials for all the 5 estrogens. And with this estrogens, we want to set up the spiking solution for the reference material. And the calibration substances should be independent from the spiking solution. And therefore, we have to choose another reference material, which are available commercially from other providers like Ernst Torfer.
And you would provide a list where we could get these kind of material?
Yes, for example.
Yeah, great. Mm-hmm.
Yeah.
Thank you.
May I ask to the attendees, just perhaps by raising virtually their hands, among the audience, who is interested or perhaps yet have yet registered to participate to this inter-laboratory comparison? And if not, what are the barriers from your side not to participate? May I ask just people who are there, who have a plan to participate to this inter-laboratory comparison?
So,
I do not see all
Gisela Brausen. And sorry, which is your, where you come from also, can you, or not? Gisela comes from Germany, I suppose.
Yes, yes, Gisela. I come from Germany and I'm in Jochen Türk's working gene group. So we have already established LCMS method for the estrogen compounds.
Okay, thanks.
Thank you.
Sebastian, I know.
Yes, so among the attendees, only 2 of you have planned to participate to these inter-laboratory comparisons. So perhaps it will change. Really, it's just a trial, as Paulo said. It's really to improve the global. You will improve yourself definitively because you will learn about that. And but it's true that if we do not have sufficient number of participants, it will be unsuccessful and we will not learn anything. And yes, if you do not want to take the floor in direct, no problem. But if some of you want to send message to explain what could be their difficulties and the reason why they feel not so confident to take part, perhaps we can, if necessary, if it's help you.
Gisela Brausen has again raised the hand. And we have a message from everything, and that are not sure to participate yet. We are currently developing on solid metrics. We have yet to test estrogens extraction from waters.
Yes, the point is, I really hope that with our message, we have not totally, I would say, discourage those of you who would like to try. It is complicated. We will not say anything, but is there a solution? We have proven that it could be achievable, even not at any cost. And we will, yes, it is not something easy to manage. It is, to me, it is the same issue as dioxin measurements. We all know that all laboratories could not make dioxin measurements. It is really complicated, and the analysis has a certain cost. It will be the same for estrogens. All the laboratories could be incapabilities to make these measurements, but it is possible. It is really possible and achievable.
Yes, Sibyl Mallets. Will the schedule for IBM will be the same? Yes. The dispatch of the material and the returning results are the same. I know that 3 weeks could be a small time, but this is our plan in order to have the final results and report and evaluation. You have to consider that we have to evaluate both ABM and chemical methods. But I think that an expert laboratory can manage to duplicate, to sample duplicate in 3 weeks. So thanks for the comprehension about the time.
Yes, there was one question about the cost. So this trial is free, totally free of charge.
Yeah.
But you have to set up your samples in your lab on your own. So we will send you only the kit, and you have to spike the water sample with the estrogens, with the DOC and the SPM yourself. So you get not a ready sample.
But it's easy to manage.
Yes.
For routine, for people who are used, it's not complicated.
So I think it should take around less than 1 hour to set up the samples and store it overnight at +4 degrees, and then it's ready for
it will be very useful that in the protocol there is a section in which but probably Sophie already told the description of the procedure for the reconstitution of the test sample for the DLC, and the video supporting also is really useful. Just to repeat what the participants will receive as a kit of 4 bottles of natural water, 1 liter each, ampoules of SPMs and DOC, and the vials containing the standard for the 5 targeted substances, plus a bottle of blank, an extra unit of bottle of water. This is like a blank to measure it for the same targeted substances. I don't know.
Yes, we have an information that from Martin Jan, and I'm sorry if I pronounce it badly, I apologize. We will participate with an IBM IES and together with 2 or 3 other German laboratories. Thank you for telling us. Thank you.
Thank you.
Are there other points you would like to discuss about this inter-laboratory comparison and or standardization process? I do not see any message or raised hands, so it seems that we are at the end of this second session. We really hope that for all those of you, we are experts in MS-based measurements. You learn things, and that all the things we have trying to share with you very honestly will be useful for you in the implementation of measurements method of estrogens to tackle WFD or to tackle any other measurements issue. If you have some comments, feedback to provide after the session, do not hesitate to contact us. You have all the address in the website and so on. For those of you, we are still not sure to participate to this inter-laboratory comparison. We will deeply appreciate and strongly encourage you to make it. You will learn many things, and
Yes, okay.
Thank you all, and bye-bye.
And see you tomorrow.
And
Thank you. Thank you. Bye.
Bye.